Angle. Yeah, which two problems deal with an exterior angle? It's on the board too. 1 and 4. So pick one of those and we will work it, and I'll let you guys do the other one later. Oh, I apologize. Okay, 1 it is. Now, there are two ways you can solve an exterior angle problem. You know what? I wouldn't really, if you guys want, we can just go through the whole thing together. Alright, there are two ways to solve an exterior angle problem. One, if you have the interior angle connected to it, if you have that angle, you can just set them up as a linear pair. Linear pairs add up to what? Well, I was going to call it somebody specific, but that's correct. Now, 1 or 4, which one of those do we know the interior angle? Number 4. What is the interior angle? It is 60. It is 60. Elon, why is this angle 60? Well, yes. And all three of them are the same, so therefore the angles are the same. That's right. So, what do linear pairs do? Linear pair. Add to 180. Right. So, what do you do things that add to 180? What? Did you just say? Did you say set them equal? Oh, no, you didn't. You add them to 180. 60 plus 8x plus 40 equals 180. If they add to 180, then add them to 180. So that's 8x plus 100 equals 180. Subtract the 100. You get 8x equals 80. Divide by 8, and what is x? X equals 10. Now, on number 1, you don't know the interior angle. Now, you could find it. There's two ways to solve this problem. How could we just find that interior angle?
You got 20 plus 30, that's 50, you subtract 50 from 180, you get 150 divided by
You're doing way too much work. What do they all add up to?
180.
180 minus 20 minus 30. Boom, you get 130. That's your last angle. Now, the reason we're not going to solve it like that is because what if tomorrow on your test, instead of giving you 20 and 30, they give you like 2x and 6x or something? Well, you can't just subtract those from 180. So the other way to solve an exterior angle problem is set that exterior angle equal to the sum of the other two interior angles. There is a formula that we learned in section 4.1. The exterior angle is equal to the sum of the other two interior angles. So 2x equals 20 plus 30. So 2x equals 50. And what does x equal? 25. Very good. That's it. These all have the potential to be easy if you know what to do with them. Now, numbers 2 and 3 are both going to work the exact same way. Someone raise your hand. Cameron, how are we going to solve for numbers 2 and 3? Numbers 2 and 3, how are we going to solve for those? That's right. And add them to what? Yes. When in doubt, add them to 180. Now we have to do all three, right? All three angles. So here we go. Number 2. 2x plus 5 plus 8x plus 25 equals 180. All three add to 180. So, like terms, 2x plus 8x, 5 plus 25, 30. Subtract 30. That's a 5 minutes. I'll give you a second to catch up. By 10. Madison, what's that going to be when we divide it by 10? What's this going to be when we divide it by 10? Nobody else say it. Ask Madison. Very good. And x is going to be 15. You know, if you want, you can kind of come around to this side so you don't have to turn completely around. It's up to you, but you don't have to. Okay. Questions about numbers 1, 2, and 4 before we do 3?
No.
Very good. Okay. Hey, Starla, how are we going to solve number 3? 2. Excellent. Add all of them and set them equal to 180. All 3 angles of a triangle will always equal 180. So like terms, 4x plus 3x, 7x, minus 5 plus 5, those are going to cancel, plus 40 equals 180. We'll have to subtract the 40. What's 180 minus 40? Divide by 7. And Elijah, what's that going to be? What's 140 divided by 7? You guys knock it off. Thank you, sir. X is 20. I believe tomorrow you can just solve for the variables, but there may be 1 or 2 that asks you for an angle, so just make sure you read the directions. Oh, oops, forgot to do that. Very good. So we need to name acute, obtuse, or right. What is number 1? Obtuse. Eeny, meeny, miny. Amber, what's number 2? Very good. Sage, what's number 3? It is a cute triangle. It's a nice, cute triangle. Sorry. Okay, I'm already in dad mode. Number 4. Tricky one. Tricky one. Malik. What? Oh, very good. I thought you said 3. In which case that wouldn't make any sense. But right, regular, which means equilateral and equiangular. I would accept regular, equilateral, or equiangular. Well, I guess it's technically said by its angle, so equiangular, but regular is fine for me. Now, tomorrow is multiple choice, so if equiangular is an option, I would go with that. The test. Questions about these first 4? Okay. Numero 5. Number 5. 5 through 8. Now, you know what I'm going to do? Now I know you have this right in front of you. I'm not even going to look at this part yet. You know why? Because we don't need it to tell us what to look for in order to figure stuff out. Look at the congruent statement. And here we go. Hey, Jensen.
Yep.
Which angle goes along with angle Z up here? How would you describe angle Z? First, second, or third angle in that thing? First, second, or third one? Right. What's the third one over here? That's how you know. So if Z is 50, what is S? 50. Congruent statements are literally that simple. Which one goes along with Q, Elijah? Very good. So what is X? Excellent. And how are we going to find the last 2? Add them, subtract. And what does someone get when they do that? Well, good question. Very good. Very good. Ariana, what do all triangles add up to? So take 180 and subtract the 2 that you have. Minus 50, minus 55. And you should get what Malik said, 75. Now, we haven't even looked at what it actually asks yet. But now that we filled it out, it'll take like 2 seconds. Number 1, what is angle R? 75 degrees. Oh, I didn't even see the sides. Well, no problem. Stacy, XY goes along with what side? Very good. XY QR. And what is it? Very good. What is the measure of angle X? Blake. Very good. And what's angle S, Blake? Very good. Questions about where we got any of that? Good question. Look at the congruent statement right here. And there are problems like this tomorrow in the test where the answer is in the congruent statement. So, we needed to find, well, you said this one first. So basically, how did we find number 8, S? Which angle goes along with S on the other triangle? Exactly. So if Z was 50, then S is 50. That's it. It's all about the order. Yes, ma'am. Yes. Other questions from this slide? Yes, sir. What do you mean? You're right. What are you asking? Well, you should. You should. Or it's incorrect. However, see, here's the thing. Actually, except for like on a proof, I don't really ever ask you to say that the triangles are the same, right? So you really haven't had to practice that. But whenever you do, he asked a good question. He said, well, why don't we do that? We should do that. We just haven't had many opportunities to. Malik, please stop. When you say two triangles are congruent, you need to put them in the correct order. In fact, there is one tomorrow where it shows, in fact, it's a lot like our DOM. Now, it's not exactly like this because I don't think there's one like, I don't think there are two. But there's a picture with those like several triangles and it says which two are congruent. Now, again, there's none there. But like you would have to say, oh, AFC and DEF and put them in the correct order. Okay, so there will be one like that tomorrow, so please know that. Other questions? That's a really good question. Other questions? Okay. Numbers 9 through 12. Now, these are very different than anything we've done, but that doesn't make them harder. State the congruence needed to show that the two triangles are congruent. Now, it's very important you pay attention to this. Number 9. Number 9. Now, hopefully you're doing this in pencil and not pen. If you're doing this in pencil with an eraser, this won't be hard. Just make very light marks. What does it tell us we know in number 9? So I'm going to come up here and put a dash through those. Okay? Now, again, if you're doing it in pencil, make it a light dash because you're going to be making a different dash for every problem. Okay? Now it says, state the congruence that is needed. In other words, what else would we need to know to use the hypotenuse leg congruence theorem? Somebody raise your hand and tell me. What else would we need to know about these triangles? What pieces would we need to know are congruent in order to show they're congruent using the hypotenuse leg congruence theorem? Yes, ma'am. Well, that's a good question. No, but if we had, here's why. If we had known these two sides as well, how would I show these two triangles are congruent? No, these are the only kinds of options. The only one that's not up here is side angle side. What would we use to show those triangles are congruent if I had known these two sides? We don't know all three sides. Trip. If I knew these two sides, just these two and these two, how would I have to show these triangles are congruent? Well, that is the answer to number 9, but you're not answering my question. I'm asking you, because someone said, well, what about AB and BE? Now, those would help you solve the triangle, but you couldn't use hypotenuse leg. If you knew these sides along with these two things, what would we have to use? That's what you just said. I know. That's not what I'm asking. Donovan, do you get what I'm asking? Thank you. That's what I'm asking. If this had said side angle side right here, then you would have needed these two pieces. Side angle side. But it didn't ask for that. It said hypotenuse leg congruence theorem, which is what Tripp kept telling me. And he said to use hypotenuse-like congruence theorem, you need the hypotenuse. You need to know that AC is congruent to DF, which is how you would answer this. AC is congruent to DF. That's what you would need to know to show those triangles are congruent. Yes, you just have to list the piece that you would need to know in order to use that part of the proof. The whole reason I said that thing before is because somebody said A, B, and DE, which would help you prove it, but you would have to use side, angle, side if you did it that way. Okay, erase. Number 10. Now we're going to mark the new pieces it tells us. AB is congruent to DE, and AC is congruent to DF. Now, again, don't just read the problem. In order to use side, 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 what do we need to know on this triangle that we don't right now? Yes, ma'am. Thank you. That's perfect. You would need to know BC and EF to use side, side, side. I don't think so. Number 11. Mark the pieces you know. A is congruent to D. This is number 11. And B is congruent to E, which is already marked. Now, there are two different things you could give me to solve this. What do I need to know in order to use angle, angle, side? Hold on. I'm calling somebody. Becca, what do you think? That would work. That's one of the answers I would accept. Or you could have known BC and EF. But she said AC and DF. Now, this is a dead serious question. I really, really want somebody to answer it. Why couldn't you use AB and DE for this problem? Why couldn't AB and DE be the sides you chose for this particular problem? Yes, ma'am. Yes. It would be angle, side, angle, which is what this one calls for, but not the one we're on. Very, very good. It would no longer be angle, angle, side. Okay, number 12. If A is congruent to D and C is congruent to F, what do I need to use angle, side, angle? Master, you're getting too many of these. I gotta call on somebody else. What is it? Hold on. Well, all of these are ways that you can show triangles congruent. Okay? These are what I've given you to use. These four is side, angle, side. Okay? So now look at this. Notice the order. Angle, side, angle. That would mean you have to know two angles, which in fact we actually know all three, and you have to know the side between those two angles. Okay? So for instance, Elon, what side lies between these two angles on this picture? What side lies between these two angles on this triangle? In other words, where could you put your dash so that it would be directly between these loops? And which side? Right here? Yes, then I would prefer you said AC. Right. You're right. That's why you would use angle, side, angle, if you knew that side. In fact, you just answered it. So, if you chose this one, what is the corresponding side on this triangle? Exactly. And that is the answer to the problem. You would need to show that AC is congruent to DF. Actually, on this one, since you knew all three angles, you could have actually used any of the sides, but that is perfectly satisfactory. Since they only gave us the ones we marked, that's probably the best answer. Very, very good. Questions about anything from that slide? Okay. Hold on. Numbers 13 and 14. Decide if they can be proven congruent, and if they can, what all would you need, not just the finished product. Donovan, number 13. Oh, I'm sorry. It's saying it's. One second. I'll still come back to that answer in just a second. I misread the problem. What it's actually asking is, do you have enough information to show that the triangles are congruent by the thing that they're giving us? So you're not adding anything unless you can. Do you have enough? And you said, why not? You don't have any angle, do you? No. The only thing, if you do not have an angle, someone raise your hand and tell me, other than Donovan and Madison, if you do not have an angle at all, what is the only thing you can use to show triangles are congruent? Trip. Very good. Do we have all three sides? No. So not enough information. So many people tomorrow are going to be like, yes, hypotenuse leg. Why can't you assume that's the right triangle? It doesn't have a box. Well, I kind of answered my question. You can't just assume that it's a right triangle. Number 14. Do we have enough information to use angle, side, angle? Safe. This one's a little tricky. Why? Oh, I'm so impressed. Very good. Are two of the triangles sharing a common side?
Yes.
RPOC is the reflexive property of congruence, which states, Cameron, if, and it'll only come into effect when two triangles are like laying on top of each other. Is there a side, now here's a question I want you to answer me. Is there a side that literally is on both triangles? And if so, what side is it? Give me the two letters. Is there a side that these two triangles share? What is it? Two letters. Very good. XW. If two triangles share something entirely, you use the reflexive property of congruence to conclude that they are congruent for both. Right? That way, if I were to pull these triangles apart and draw them separate, I could put a dash through those because they were at one time shared. So, this would be yes. And technically, it's just a yes or no question, but technically if this was to be solved, you would need to state the reflexive property of congruence first. Very good. That was a potentially tricky one. Next side. 15 through 18. Ooh, I'm going to need some participation on these that I will pick on. Guys, I appreciate it, but I'm going to pick on people at random. Number 15. Rachel, I don't think I've called you today. Let me just ask you this. What is the key in this problem? What do you think is the big hint in this problem? Exactly. They gave you that the angles are congruent. You see that? Base angles converse states if the angles are congruent, then their opposite sides are congruent. It is an isosceles triangle. Elijah, how am I going to set up to solve this problem? If they're congruent, what does the word congruent mean? So if whenever you say that word, what should you do with the two things? Exactly. We're going to set them equal. 4x plus 12 equals 3x plus 15. Whenever you use the word congruent or equal, that's what you're going to be doing in the problem. So, minus 12 4x equals 3x, what was that, plus 3? Minus 3x on both sides. And you get x equals 3. Now, sometimes they won't give you dashes or loops, and they'll just come right out and tell you two sides or two angles. So, in that case, Stacy, how can I solve number 16 for x? That's exactly what you would do. Because the sides are equal, then you know their angles are equal. That's the base angle theorem. Therefore, the two things equal each other. So, subtract 8x from both sides. What's 6x minus 8x? Very good. Equals negative 22. Divide both sides by negative 2. And what is x going to be? Very good. 17 is a mean problem because they give you more information than you need. So please listen to the question I asked before you say something. Rebecca, on number 17, what piece that they give us do you not need at all? It is the 70. Don't need it at all. So, Clay, I know it's your first day, and I'm going to throw you to the wolves here. Which two things can I set equal in this picture? Very good. Base angles converse. If the angles are equal, then the sides are equal. 3x equals x plus 18. Let me change colors. So, subtract x from both sides. 2x equals 18. Divide by 2. And x equals 9. Before we go on to number 18, are there questions about the first three? Elijah. Eye of the tiger on this one. 18. What do I know about that triangle? That's right. So what do I know about the angles? That's right. So how am I going to solve this? You demand. 2x equals 60. Divide by 2. And x equals 30. All right. Feeling good. Yeah. I'm psyched. I feel like tomorrow's going to go well. Let me dream. Let me dream. Okay. I know the tests are always harder than these because there's not a teacher yelling things at you, but I'm still feeling good about it. Just make sure y'all look this over tonight. Alright, we're not done yet. 19. Ooh, this is stuff we did yesterday. Yesterday. All these problems seem so far away. What? What do you mean it's not on the lines? Let's see. Hold on. Let's see. Alright. Oh, I see what you mean. Gotcha. Okay, I get it. Oh, that's right. Number 19, you may notice, is on a scale. Notice that the axes are on scales of 2, which means, what would this coordinate be right here? It would be negative 1, 1. What would this coordinate be? Negative 2, 2, 4, 5. Negative 2, 5. And the last coordinate would be negative 2, 4, 5, positive 5. Yeah, it's just going by 2s, that's all. Now, Time to pick on somebody. Hey, Jensen. What do I do to these coordinates? You. Well, they're already graphed. So, how does this affect our coordinates? Let me give you a hint. What do you think you do with the x values? Why do you think I just put an arrow to this plus and this 7? That's exactly what you do. You take the three x values and you add 7 to them. So what's negative 1 plus 7? 6. I'm just going to do all the x values first. What's negative 2 plus 7? What's negative 5 plus 7? 2. 2. Now, we still have to find the y value. Miss Darcy, what we gonna do to the y's? That's exactly. That's right. Negative 2. It's alright. She told me how to do it. How do I find the next one? Which would be 2. Very good. And the third? 2 again. Now, Jensen, you said I should do this like 3 times in the last part. Say it again. What should I do with those points? Yeah. Graph them. 6, negative 2 would be, don't forget it's still by a scale of 2. 5, positive 2 would be, and 2, 2. Connect your dots, and you should see that it's just a translation of our original. Right 7 units, down 3 units. Now, I'm not mad. I want y'all to do number 20 on your own. Sorry. I've been watching Paula Deen on the cooking. No, I'm just kidding. Alright, number 20. Graph it yourself. Graph number 20 yourself. And let's see if ours look the same. Man, I'm kind of like stuck in this feminine mode. Just graph number 20. And we'll see if they look the same. Comes from coaching girls all year. Even ones that have weird connections with their uniform. Yeah. Don't even ask. I will put mine on the board. You may compare it to yours. Here's my finished product. Here were my original coordinates, and here were my after translation coordinates. I should hang a mirror over there. So that the reflection, which may have something to do with number 21, would be visible. You object?
Okay, it's not on two though.
Here? My drawing's not perfect.
No, not that one. Okay, the original setting is on the left.
Here?
No, not that. Oh. Going by two, bro.
Yeah, it's going by 2.
On by two, on by two. Oh,
Oh, stop. I know, we haven't really done anything like that. It's a little different. Yeah. So if yours are all, and here's the thing, Trip. Is yours the same, just all scaled down by 2? So like 1, 1, -2, 3, etc.
like off the breath.
Oh. Yeah, you probably want to change it. Are there questions about where we got anything that you currently see on the board? Yes, no. Feeling good about this review. Focus, dude. We're almost done. You can see where the end of it is. I don't even think we're going to do some of the last ones. Okay. Can I take this off the board? Just kidding. I wasn't going to. No. Blake, you know I see that, right? Take a drink, hurry up. I don't know, so I don't know why he's hiding it then. So why are you hiding it? You are in a good mood. Alright, taking this off the board. About what? What do you have a question on? Not until we get this finished.